this section, we're talking about how we can calculate the amount of work done during a thermodynamic process. We had talked about how the work is equal to the pressure times the change in volume. However, this is only true if it's an isobaric process. In other words, the pressure has to be constant in this situation, like the graph on the right here, constant pressure. And so we see that if we multiply the pressure, which is from here down to here, times the change in volume, this being our change in volume, we are essentially finding length times width of this box. Or in other words, we're finding the area under this curve. So the work done is equal to the area between the line and our horizontal axis if we are given a pressure versus volume graph. But what if it is not an isobaric process? What about the situation down here where the pressure is changing? What do we do in that circumstance? Well, we use the same process in that we are finding the area between the line and the horizontal axis. So that area is still equal to our work done. So we are going to now use geometry. You could use calculus and integrate, but in this section, in this class, we're only using algebra-based physics. So we're just going to use geometry to find the work done. So in this section, in this case, what we'd have to do is we'd have to find the area of this triangle, which is 1/2 base times height. And we'd have to find the area of this rectangle down below, which is length times width, and then add the two together. Now we want to make sure that we're in the correct units though. So if we want to have our work in joules, we must have our pressure in pascals, and we must have our volume in cubic meters in order for this to work out. Now we can get positive work and we can get negative work. We have positive work if the if the volume increases. So positive work occurs when the volume increases. We can see the volume increases because the graph would go to the right. So they're going to give us an arrow here showing the direction in which this transformation is taking place. So the graph moves right. Negative work is done in the opposite situation, when the volume decreases or the graph moves left. What we want to do in this next tutorial is figure out how to actually go through these derivations and calculate the work that is done. And so we'll actually go through a couple examples together. So again, the work is equal to the area under the curve. Now in calculus that's called integration, but we're just going to do it through a geometry view here. We're just going to find areas. If the direction is to the right, we have positive work. If the direction would be to the left, we'd have negative work. And then we just have to find the area of all of our different shapes and add them together to get the total.